Let's turn our attention now to how we'll construct truth tables for formulas and arguments that we want to evaluate. So the first thing you might want to ask is, well, how do I even get going here? So here's Alan Torrey, mathematician and logician, to give us some advice. So we're going to start off by drawing crosshairs. Divide up into 4 sections here. On the top part, we'll put the individual constitutive letters for the simple statements. On the top right-hand side, we'll put our formulas. We'll put our guide columns here and our truth values for the formula here. Now, how many rows do you need? How many possible ways can the world turn out? Well, it depends on how many simple constitutive statements we have. Each simple statement has 2 truth values, so every time we add a simple statement, we add 2 possibilities for every possibility that existed before. And so we'll need 2 to the n rows, where n equals the total number of propositional letters. So 2 to the second 2 letters will be 4. To the first 1 letter will be 2. To the third 8 letters will be, 3 letters will be 8 rows. Once we do that, we can make sure that we capture every possible combination of truth values by filling in our guide columns in this very systematic and mechanical way. We'll start with the innermost simple statement, the one closest to the crosshairs, and we'll alternate off true, false, true, false, true, false, true, false until we get to the number of rows we need. Then we'll go to the next one and we'll double the numbers of trues and false in the pattern. True, true, false, false, true, true, false, false. And we'll do that until we get to the end. And when we're done, our outside row, the top half true, the bottom half false. Our inside row, true, false, true, false, true, false. And then slowly every difference in between. So if we have 2 propositional letters, that means 2 to the second n equals 2. That means 4 rows. So here we go. Our simple constitutive letters go up here in our crosshairs. Our formula goes up here, top right in our crosshairs. True, false, then true, true, false, false. If we have 3 propositional letters, that means n equals 3. 2 to the third is 8, so we've got 8 rows. We draw our crosshairs. We put our simple letters, upper left, formula, upper right, alternating off to create our guide columns on the lower left, like so. So our simple constitutive statements, our formula, true, false, true, false, true, false, true, false, 8 rows. Then go to the next one, true, true, false, false, true, true, false, false. And finally, true, 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 false, 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 false. Once we've got that in, how do we go about filling out the body of our truth table to determine the truth value for a formula or formulas over on that right-hand side? We'll start off by copying all the values from our guide columns. We write out the guide columns so we have this canonical assignment. We copy them over so we make sure that we have them right there available to us. We're not looking back and forth. We're not overtaxing our working memory. All right? And then we start like we're little logical insects. We start at the inside, the connectives with the most parentheses around them, and we work our way out. Suppose we have the following formula here. Tilde, parentheses, P, dot, tilde, Q, parentheses. We put our simple letters up here, simple statement letters. We put our formula top right. Below Q, We alternate off in our guide columns, true, false, go out to P, double that number in the series, true, true, false, false. Now we've got our 4 rows, one for each possible way the world could be. The first thing we do is copy over those truth values from our guide columns under each of the instances of those simple letters. So P gets that, Q gets that. Now we're ready to evaluate our logical connectives and ultimately the whole sentence. We start inside our parentheses here. We've got 2 connectives. Tilde always goes first, followed by our dot. So tilde reaches out and grabs Q. Our rule for tilde is opposite truth values of what it negates. So Q is true, false, Q is false, true, Q is true, false, and Q is false, true. Now we've got our truth value here for tilde Q. Tilde Q is one conjunct, P is the other, so now we're going to evaluate our dot. So our dot then, that connects P and tilde Q. So we look under our tilde, we look under our P. Our rule for the dot is, can you say it? If not, rehearse it. Conjunctions are only true if each conjunct is true. So when we look at this, we fill it in. See if you can fill it in. All right. True, false. That'll get you a false. One of them is false. True, true. Only way to make a conjunction true. False, false. That'll get you a false. And false, true. Still has one false, also false. That gives us our truth value now for everything inside our brackets, right under that dot. Now we go outside of our brackets and we've got our tilde. Tilde everything in here. So we go to the last connective that we did inside the brackets right here. And now we're going to evaluate our tilde by looking at our dot and using our rule for negation. Our rule for negation is, if you can't say it, rehearse it, opposite truth value of what you negate. False, true, true, false, false, true, false, true. This is the last connective that we do. It's referred to as the main connective. It gives us the truth value for this whole formula, every different way the world could be. In our next module, we'll do some more examples of this.